I am so looking forward to this next 20, 25 or whatever minutes we get together. One of probably my most favorite conversation partner in the world. Please welcome Steve Jurvetson. Steve? Welcome. Come on, sit down. Well, Steve, a lot of people, this is not, who are not from the Valley, not necessarily from the VC tech world. I mean, you're kind of a legend. You are kind of a legend. I mean, you've been a VC, just celebrated 20 years. Congratulations. It seems like only a few years ago you were being bar mitzvahed as a VC. But you've been at the beginning at Hotmail, really the iconic companies, the web as a platform, Tesla, auto and energy fusing, and on and on. And so we're really interested in talking about sort of the platforms of as we go forward. And I know that you've got this amazing intellect around topics like deep learning and artificial intelligence, and we'll get to some of those. But first of all, just sort of level set. First of all, give us a little bit about
the panel was all about.
DFJ,
deep learning.
A little bit about DFJ.
Okay, sure.
Just people who don't know.
Sure.
Fisher Jurvetson.
Oh, sure. So we are an early stage venture capital firm, and we have been actively investing in what obviously is of interest to folks here in sustainability, whether that's on the energy side or the clean tech side, for quite a while now. I think when it was called clean tech investing, we were the most active venture firm for the first 3 years in a row. And that includes companies like Tesla and Enernoc and Lighted, which is, I guess, one of your sponsors. And has been along sort of the avenues of energy efficiency primarily, and then better energy generation and storage secondarily. And that continues to be our investment themes. I personally have gotten very interested in synthetic biology, ways in which we can grow food more efficiently, everything from algae to aquaculture. And we'll be continuing to look for new things. So maybe the best answer to your question is that I think of DFJ and want to think of DFJ as a firm that will continually try to find the next great technology waves, whatever they may be, right, as opposed to defining ourselves as tied to any one industry.
Yeah, well, you talk about clean tech, and a lot of VCs don't talk about clean tech anymore. They either they don't talk about it at all, or they just talk about tech, or specifically energy, mobility, or other things. How do you view what we traditionally have called clean tech?
Well, it's an interesting question. The broader community tends to flock in waves to whatever they think is exciting. It's like the sugar buzz du jour. And some of the opportunistic, arbitrage-seeking kinds of folks, whether they're entrepreneurial or investors, they come and go pretty quickly, and they're on to whatever the next hot thing is. I don't know that that's the best way to define an industry. So if you look at a SolarCity or a Tesla, they've done quite well as an investment. Are they mainstream? I don't know in that sector. So I don't actually personally think about industry sectors much. I try to look for technology themes that span across industries, things like deep learning, or generally like the concept of sustainability within a company is one of those sub-themes. If you had two choices, a sustainable startup or one that's not, you might find more opportunities for growing your business in a way that looks like it'll scale and have legs for the future if it tends to be a sustainable business for a whole variety of reasons. Similarly, purpose-driven businesses are much more attractive to me than ones that are just trying to make a quick profit or just make profit as their primary mode.
Why do you think that's still sort of out there thinking in the Valley, in the Valley venture community? That's not how most companies, most venture VCs still see it as sort of a purpose. I mean, rarely comes into the conversation.
Well, I'm not sure, and it's disappointing to me. I could guess that it might derive from the goals of the investor themselves. If they're a banker mentality or a financier by mindset, and they're thinking, I'm here to make money for my limited partners, which ostensibly we're all supposed to be doing, if that's where they start, then they might end up looking to maximize that in any kind of time frame, short-term, medium, or long, but generally they're just thinking, where can I make a buck? The same is true for startups, by the way, and there's an analogy here. Whereas if you start from, how can I have impact? How can I really, in my career and in my life, make a difference that's meaningful, something that hopefully people will be proud of, and that maybe one day will make a meaningful impact on the world and ideally be written up in history books, that would lead you to a whole different set of investments where making profits is a byproduct of your mission. So I think of Tesla, and I think of Planet Labs, and I think of a bunch of companies that openly state that, here's our goal. It is not profits. Profit is the and then as an investor, you can do the same thing. And so perhaps I've, over the years, gotten comfortable that that is a defensible financial strategy, and our investors won't, beat up on us too hard if we say, or at least if I say that I'm not trying to look for the quickest profit maximization for them.
Yeah.
Right?
One of the interesting things to watch in a lot of these companies, and you've mentioned some of them, is how they end up being kind of in a different business than at least we initially thought. And Tesla's a great example of that. You're an investor. You're on the board?
On the board, yeah.
Or did you get an X? Yeah, Tesla X?
Yeah,
Okay.
the second one.
It's in the Valley parking right now? Yeah.
Actually, the sedan
Okay,
is
all
in
right.
the
The other Teslas. All right, that one's in the shop. No, not in the shop. It's, people describe Tesla, they're posing as a car company, but they're really an energy company. They're really an energy storage company. Obviously, the Gigafactory in Nevada that they're building. And that's really, the cars is really the first platform. Is that how a lot of these, first of all, do you see that about Tesla, at least in terms of what you can talk about? And is that where a lot of companies sort of go in terms of creating a product and then using that as a platform to really create a much broader number of products and services?
To your latter question, there are a lot of great examples of that. That if you can migrate from being a point product where you launch to something larger, like Flux, which you just saw launching this product, Quartz project that you just, is a great example. Or companies like Planet Labs, starting with imagery, but then becoming a software platform for developers. That's generally true. That's generally a better place to be. You build a rich ecosystem of things hanging on your product or a platform. In the case of Tesla in particular, put it this way, they clearly today are primarily an automotive company, but then there's all kinds of interesting ways to look at why are they different, how do they succeed. Some might say they're a software company, interestingly. Right. 5 million lines of code on wheels, on over-the-air updates. There's a lot of reasons why they're different from most other car companies, over and above the fact that electric drivetrain inherently has certain advantages if you engineer it in. So I think of them as a electric sort of, Elon's founding dream for Tesla was to catalyze the conversion of all vehicles to electric drivetrains. So cars, trucks, motorcycles, trains, planes, everything. Even parts of rockets, even though he meant to exclude rockets, but let's say all terrestrial transport. And to help catalyze that change. To do so, you have to have a business model people want to copy because it's better than the current business model. Therefore, profits as a sub-effect reaches his goal of inspiring others. But moving into Powerwall also, and this is the storage product that is, and Gigafactory are integrated with his vision with Solar City, right? So Solar City, one of his 3 companies, the guy's clearly a polymath, has the image of a distributed utility that every home and business can generate the power we need for the entire planet. The missing link is storage. So if you think of those 2 companies and don't sort of fuzz out when and who does what, you have the complete vision. Storage, generation storage, and at least one of the compelling apps, which is driving around and getting off oil.
Right.
We spend $2.5 billion a day on oil in the United States, and there's no real reason to do that without transportation. That's what consumes the vast majority of it. And
so let's move to deep learning, because that's what we came to really to talk about.
We're here about deep learning, yes.
First of all, for those who haven't, whom that term does not resonate, what is deep learning?
Sure. Everyone likes a new euphemism to warm over something that came and went in the past. So in the 80s, there was a term called neural networks, and I studied that. Actually, started a PhD in that area of all things. And it's quite simply, how can you mimic the brain by connecting a bunch of virtual nodes that look very much like neurons and synapses between them, and you have a generic learning machine. You have a series of inputs, thing that looks like a brain in a box, and some outputs. And you can train this generic brain to learn things, to learn how to recognize human speech, to recognize cats on the internet, whatever it might be that you want to do. And it turns out, much like our sensory cortex, it does a really good job at things that feel like vision system, auditory system, and so forth, weirdly recapitulating evolutionary biology itself, which is an aside. In the 80s, because of compute powder, where Moore's law was at the time, it had limited applications. And then through the 90s, it powers most of the speech recognition systems underlying Siri and all the image matching stuff you see on the internet today. It will increasingly define what we feel is magic over the next few years, like autonomous driving, your calendaring system, knowing in a really spooky way more about you than anyone else has ever known about you, where you tend to be late, or what you're doing in your life. And the way it does so is it just is a generic pattern recognizer. So to your question, deep learning is the new term for what used to be called neural networks, with the added twist that under the covers, there are some additional little technical details that make it learn better, maybe more efficiently than even the human brain in some cases. But the analogies to the brain are the simplest to understand. Instead of programming something to do something, you generate a computer program that is itself, like our brain, capable of learning anything, So an analogy would be like a newborn baby could learn, human baby that is, could learn any language of the world, but they never learn all the languages. Any one baby learns one or maybe up to 5 or 6 languages in its life, and that's it. Same for these brains in a box. The same piece of code could be applied to many destinations. Every business could use them, frankly. But it's the same generic blob of learning capacity applied to different problems.
Same generic blob doesn't sound quite living up to the incredible sophistication of the technology.
Well, until that blob is smarter than humans, then it gets pretty interesting.
What's interesting to me, one of the many things that's interesting to me about this is that deep learning is about systems that adapt. Mm-hmm. And in the world of sustainability and cities and buildings and mobility systems and energy systems, increasingly it's about adaptation to real-time information, adaptation to shocks, climate, natural disasters, possibly cyberterrorism, or any number of other kinds of things. And so I want to explore sort of where this fits into the world that Verge is about in terms of how deep learning can accelerate sustainability solutions, and where sort of might that begin to fit in? I mean, let's specifically look at climate, for example. We're talking about coastal and cities adapting. We're talking about any number of things that we're not really sure are going to happen or how quickly they're going to happen, but being able to be one of the terms du jour that we've been talking about here is resilience. And so how does deep learning, where do you see the applications?
Oh, that's a great question. It may be most difficult to jump to the abstraction of climate change, which is the end goal, and think perhaps to start, what are all the ways in which we can contribute to that, which could be optimization of things, route optimization for shipping and driving trucks and what have you, right, in logistics, building optimization, and maybe I'll mention a bit about each of these, obviously transportation and autonomous driving, agriculture, and how best to, in a sense, accelerate the evolution of food production such that we can grow what we need in the next 50 years, which is more than all food that's been grown since the invention of agriculture. That's a pretty daunting task. We have to do that in the next 50 years. And in each of these cases, what they have in common is you're trying to find a pattern or optimize. These are, in a way, two sides of the same coin. In a domain that is complex, that may exceed human understanding, meaning it may never be possible that the best minds on the planet will figure out the solution, which is an interesting problem to deal with, yet we have software algorithms that can crack that and to, in a sense, transcend human intelligence to build solutions beyond our own understanding. That's really what we're talking about here. Now, how does that apply in all these areas? Take buildings, you mentioned. A company, Enlighted, who you may hear about one of these days, I don't know if they've yet been on the stage, puts sensors on all the lights in a building and thereby measures temperature and light everywhere. So it's the Internet of Things for buildings. What they find is they can reduce energy consumption by 2/3 and HVAC, in a sense, non-lighting related energy by 1/3. And oh, by the way, in monitoring what actually happens in buildings, they realize that 20% of all commercial real estate is wasted. You could optimize. And so how do you figure out how to optimize? Well, you take all that reams of big data coming from sensors, the Internet of Things, be it weather sensors outdoors or building sensors indoors, and then apply the deep learning algorithm, the brain in a box, if you will, to figure out, wait, what are the patterns of activity? So for example, in buildings, here was a surprise for me today that I didn't realize they were already doing this. Look at where people move and make better predictive algorithms of where the elevator should go. So don't wait for the button pushes to indicate where the elevator should be. Notice the pattern every day around certain parts of the day in ways that no human bothers to look or study. Here's how, and then run it, of course, through an optimization algorithm. Here's where the elevator should predictively go in a complex elevator bank. One of many examples for occupancy planning, what have you. So just think the buildings being a huge energy consumer, you can do a lot. Step out to transportation. We don't need to build any more roads primarily, and we can accommodate all growth in traffic if we just make all cars autonomous. Well, how can they be that magical, almost human-like intelligence in how they drive? Well, under the covers, the higher level decision-making that we make, like should I swerve or not, is going to be a deep learning harness on other layers of technology. Maybe one last example that I think that relates a lot to climate and understanding our Earth is the satellite imagery companies. So as Planet Labs and others, right, over the next 12 months, put up hundreds of satellites to look at every part of the globe every day and monitor ocean health, monitor crop health of every square meter of the Earth. There's just too much imagery. There's already too much imagery for any bank of humans to find interesting images. So what do? They first have humans say they like a picture. Well, that's interesting. That's relevant. This is fascinating. This is whatever, interesting. and then they feed a deep learning algorithm to then scour all the pictures that no one's looked at to find similarly interesting things like new construction or a fire or a blackout at night. And it can automatically detect, oh, these are the kinds of images humans find interesting, but now I don't know why, but my brain in the box is finding me all those images that are like that.
So a lot of this is about making infrastructure less brittle. And,
Oh, yeah.
I mean,
Oh, sorry, I forgot to get to that point that you mentioned. Yes, when you build or engineer a system, it tends to be brittle. It tends to do what you expect. This is the Germanic, command and control, the Lego building block metaphor of engineering. It's kind of what we were trained as engineers. You build something to do what you want, and if it doesn't, it's a bug. Kind of like Microsoft product stack, just a bunch of bugs, right? But when you evolve them, you don't have the same degree of control. It's more like parenting than programming, right? So you may hope to parent something that ends up being a good teenager that does you proud and does well in the world, but you can't go in later and tweak a neuron or two if you made a mistake, right? That is a apt metaphor for this programming modality. Yet, that teenager may adapt to things you never anticipated, may do the right thing in situations you never trained it to see, and will be much more robust and resilient. And that's true of evolution in general, that these processes of building complex systems using evolutionary algorithms, using genetic programming, using machine learning, deep learning, they all have this attribute. They tend to be robust, resilient within whatever their training environment was. But the thing you build is completely unscrutable, just like a teenager.
is there a dark side to this where robots start taking over our jobs? And I mean, I know that seems to be a fear that we hear a lot about.
Yeah. But that's inevitable. That is the glib answer. That'd be Google's answer. It's like, we welcome our robot overlords and may they, have the alphabet.
Well, but there's a way.
No, but I have a different answer.
Okay. Well.
So that's not, the buck doesn't stop there. There are two ways to look at it. I think in the sci-fi modality of imagining futures of AI, suddenly out of nowhere, the robots become sentient or self-aware. They just wake up one day as if they weren't there, and then all of a sudden they're there, which is, of course, not going to happen that way. And they want to take our food or something. Like, it's just so nonsensical. If you jump far enough in the future,
It's when they want to take our smartphones that it's all over. But,
So if you shift your thinking from in the current day, will they take my job today, and instead say, just as a thought shift, would you want your great-grandchildren to be smarter, healthier, and live longer lives than you do? Most people say yes. And so this sort of selfish sense of supremacy that humans have, like the evolution ends here, we're the best that we'll ever be, like the entire arc of evolutionary history somehow ends with us, obviously false. And if you think of it as parenting or generational birth, you want to improve the next generation, and it won't be your job they take, it'll be improving a future world we live in. And if they're smarter than us, they'll probably be less violent than us, they probably won't want our resources, they'll probably help us develop like fusion reactors or whatever it might be, that a greater intelligence could help everyone. So we may feel like pets in that future world, but I think we won't even know we're pets. And more relevantly to the present, that's the future, is on the path from here to there. It won't be a step change. It'll be the autonomous cars, the smart calendaring systems, the things that infuse our intellectual world of the day, and make us more effective at every step along the way. And that will just be like a gradual transition.
It's the kind of stuff that won't make good movies, but it will just make better lives. Lauren, let's see if we can get a question from the audience.
Oh dear, I didn't know.
We have people on both Twitter and our online chat that are trying to parse some of these themes you were talking about early on, looking for purpose-driven companies against trends we hear about like B Corps or impact investing. How do you sort of draw between those different areas?
You know what? I want to go past that because I want to stick to the tech piece of this than the purpose piece. Is there another one, or should we?
Well, quick answer. You don't have to do a B Corp. We have mainly seen companies are able to do it through different voting shares, like 10x voting for the founders so they feel secure in their job and they don't have to worry that some future board or future investor syndicate will kick them out. And so you can look at Google and Facebook and a number of startups, and that's sort of the easier way to get there. And the B Corp may or may not be another way to do that. I do worry a little bit about litigation risk with B Corps, but the goal of being purpose-driven and having founders that are going to stay with the company and make that dream a reality is something we celebrate.
Well, one of the things we hear about the Internet of Things is that everything is connected. We had Martin Fink from HP on stage talking about that IT is currently using 10% of energy, and the amount of IT is going to grow 10x, and that's unsustainable, and how they're thinking about that. But part of the question is does everything really need to be connected? And are there some ways maybe where deep learning can address what really needs to be listened to or connected or online at any given time, that maybe start to solve some of these issues of the energy and resource use that all this IT is going to create?
Well, I'm not sure, but it would seem, I mean, hearing your question, I have not heard a question like that before. It would seem that you could optimize the collection of data itself, that over time, the learning algorithms could, in fact, help sort of guide, well, you know, we really don't need the inputs from this part of the grid to make a smart grid. Here's the place where the terminal nodes really give us all that we need for information. I do think part of the IoT revolution is not to purposely put these sensors everywhere, but just to take advantage of all the ones that are already there, and the data is just disappearing because no one knows what to do with it. I mean, there are an insane amount of images, an insane amount of data collected every day from these systems, terabytes of data coming from vehicles driving on the roads. I mean, think about all the temperature sensors in your car. Right. Where does all that data go? Nowhere, right? All the temperature sensors in phones, the barometric sensors that are in many of these phones, like in the case of Apple, just to tell them if they've dropped it in the water and voided your warranty. You know, this data exhaust is just disappearing, right? Yeah. And when you collect all that for free, more or less, the question is then what would you do with it? And in short, big data would be a big problem, but for deep learning. So in other words, it shouldn't be called big data. Big data is the headache. Deep learning is the solution. And you just feed it to the brain. And
yeah. You've described yourself as a techno-optimist, and I don't think that's news to anyone who's been listening over the last 20 minutes. Are you truly optimistic in terms of technology's ability and deep learning and artificial intelligence, we haven't even gotten to synthetic biology and some of these other things, to address the big challenges we have around global unsustainability with food, water, housing, energy, resilience, and all of that? Are you really, I mean, leave us with a realistic sense or a incredibly optimistic sense of what's going on?
Yeah, I mean, well, it's hard to be a techno-pessimist if history is your guide, in that as you look at the long arc of human history, technology, broadly defined, meaning things we build, processes we invent, like the scientific method as a process of accumulating knowledge over time, forms of governance as a trial and error experimentation around the planet of what forms of governance work best with collections of humans. The cultural evolution itself is a manifestation of this. Our technologies, in a sense, represent our accumulated learning. They are compounding exponentially. The body of knowledge we have that can be recombined to form new knowledge just keeps growing. That is synonymous with progress in my mind. It doesn't always mean, of course, progress happens without setbacks, that there aren't possible risks and dangers of any given new technology, given its power and ability to rearrange the world. So with power comes great potential to do harm and good, but the net vector is positive over time, and it's hard to think of something else that you'd bet on in a reasonable time frame to make a difference, like politicians getting their act together, economists figuring out the economy. Yeah, good luck. I mean, if you had existence proofs in the past of economists figuring out the economy, then you'd bet on them, but it just hasn't happened yet. So I'd rather bet on technology as being the path to finding solutions, and not just technology, but frankly, entrepreneurs, be they large companies or small, mostly small, and if they're large companies, usually small teams doing something completely unrelated to what the large company is all about. That will be the vector of progress that will address all these issues. Yeah. So when you look at climate change or income inequality or water scarcity, any big problem of the day, and you ask yourself, what do I feel is going to be the most likely good news story here 20 years from now? It's going to be a technology-driven story.
Yeah, that's good news to a lot of people in this room for whom that is exactly how they're viewing the world. So thank you for that. Please join me in thanking Steve Jurvetson.
Thank you.
Thank you.